Good morning. Thank you for joining us for today's Mobile Master Chat. My name is Amy Lunsing-Tate. I'm the Executive Director here at the UW Alumni Association. This series is made possible by our sponsor, UW Credit Union, and today's conversation is also generously sponsored by the George Kelks Memorial Lecture Fund. Thank you to you both for supporting this important programming. So today we have a special treat for you. We're thrilled to welcome a panel of exceptional UWM students from the College of Engineering and Applied Science. These students took first place in the Ramble Spark competition last December. Ramble Spark is a think tank style competition and would also select students from diverse universities compete to solve real world challenges alongside industry partners. Spark began in 2013 as expanded to competitions across the US, comprised of many universities and Fortune 50 companies. Please put your questions in the chat at any time that they come into your head. We'll kind of harvest those at the end and share them with our moderator so that we can pose them to the students involved in this great competition. So without further ado, I turn things over to Dr. Hector Bravo from College of Engineering, who can explain a little bit more about how the students were selected for this challenge.
Thank you, Amy. I am Hector Bravo. I was a professor of civil and environmental engineering between 1991 and 2021. I taught courses on water resources engineering and conducted research on water-related problems. For example, modeling the circulation and thermal regime in Lake Michigan, particularly in Green Bay. Also problems such as the transport of bacteria and phosphorus in the near shore of Milwaukee. During my tenure, I also served as department chairman and interim associate dean for research. The College of Engineering and Applied Sciences participated in the 2019 Spark competition, and that participation was very successful. That competition was held in Milwaukee in person. In 2021, Ramble invited us again to participate in the meeting that was going to be held virtually. Also, Ramble shared information on the industry partner for the competition. That was Aguaclara Reach. Aguaclara Reach is a nonprofit organization devoted to providing pure water to communities around the world. The way that Aguaclara Reach fulfills that mission is by transferring technical expertise to local partners who, along with Aguaclara Reach, have built water treatment plants in countless communities around the world. For the 2021 competition, Ramble recommended recruiting a team of up to 6 students with diverse background in their junior and senior year. And the students could be in engineering, on science, or sciences, but a variety of backgrounds was encouraged. And each team could include up to 1 master's student. With immense help from Jeannie Clamp, who is a senior academic advisor at the College of Engineering and Applied Science, we compiled a team of students. The college provided some logistical support between a kickoff meeting for the competition that was held on October 22nd, the submission of the video presentations that was due 3 weeks later on November 12th, and the final video presentation that took place on November 18, 2021. We also provided some recommendations and contact information on sources that could help with the problem to be solved. That said, it was the students that you will meet soon who did all the real work and deserve the credit for winning the competition. I will now turn over to the moderator of this chat, Carrie Bristoll-Groll, and through her, we will learn about these exceptional students and the product that they developed to win this competition. Carrie?
Thank you, Dr. Bravo. My name is Carrie Bristoll-Groll, and I'm the Principal Civil Engineer and CEO of Stormwater Solutions Engineering. I was one of Dr. Bravo's students, and it seems one of his first few years in the early 1990s. So I graduated with a bachelor's degree in civil engineering from UW-M in 1994. I started my career working for a few local municipalities as a civil stormwater engineer. And then in 2002, I founded Stormwater Solutions Engineering, who now just turned 20 years old. We're very excited about that. We have a staff of 10 water resource professionals located in the Global Water Center of Milwaukee. And I'm also the inventor of a patented rainwater harvesting device called Storm Garden, the ad for which is shamelessly over my shoulder over here. I am excited to dive in today to this conversation with UW-M students Hala Idrissi, Zach McFarland, Tessa Parrish, Kaveri Salunke, and Melissa Schussman. Before we begin our conversation, though, we're going to pause and watch the winning design video.
Hello and welcome to UW-M's video presentation for the 2021 Spark Design Challenge. In this presentation, we'll be giving a basic overview of the process we took from the initial problem statement to our final conceptual design. My name is Halah Idrissi, and I'm currently studying mechanical engineering. For this year's Spark Challenge, our team had to design a system to safely reduce or reuse wastewater sludge in a way that doesn't harm the surrounding environment. But before we jumped straight into the design of our system, we decided to outline 4 basic parameters to guide us along the way. 1, we would be designing for a climate that is hot and humid, seeing as most Aguaclara plants are built in Central America and India. 2, we focused on designing for the plant location of Gracias, Honduras, because it's one of the largest treatment facilities that Aguaclara has done. 3, we limited ourselves to only use gravity-based systems in our design and add minimal additional manpower so staffing and electricity shortages are as little an issue as possible. And 4, we finally assumed that the source water coming in from the river had little to no hazardous waste that would require filtration beyond what Aguaclara's base design provides. With those parameters as our guide, we had 2 end goals for our final design: find a way to dewater the sludge and make it a viable solid, and 2, to find a practical and necessary use for that final solid. With that, I'll hand you guys over to Zach for the mechanical overview.
Here's a closer look at the agitation chamber. It's essentially an angled box leading from the inlet pipe to the outlet pipe. Polymer is added at the inlet pipe. The agitation posts disturb the flow of the sludge, allowing time to coagulate before it reaches the outlet pipe. Finally, we have the compression chamber, which is comprised of 2 main parts: the pressure system and the pulley system. The compression chamber is engaged by releasing the crank wheel at point 8. The offset angle of the steel plate at the top of the pressure system ensures that the leftmost portion of the bag, point 3, will be compressed first. This is important because it keeps the direction of flow towards the outlet pipe. As compression continues, The spring, point 0.5, will also compress, allowing for more pressure to be applied to the rightmost portions of the bag, point 0.3. Keep in mind that the pressure system is at a 45-degree angle, allowing for water to flow from 1 to 2 continuously.
The polymer we envision using for the agitation chamber step is a cationic polyacrylamide known as CPAM. CPAM is a dry cationic polymer that has a low dosage requirement, high efficiency, and a pollution-free effect when applied to the environment. This step should bring the solids content to around 70% solids with the recommended dosage of CPAM, which is 4 milligrams of CPAM per gram solid in the sludge. The final dewatering step will be performed in a woven polypropylene bag. They are extremely water resistant and are woven so that water will seep out, but our coagulated solids will remain inside of the bag. These bags are low cost, reusable, and easily transportable. Large 150-gallon sized bags can be used to store the entire amount of the 1 meter cubed flock copper without concern of outflow. But standard size polypropylene bags will also work if water outflow into the bag is slow enough. The benefit of the smaller bag is that they are cheaper, and they may also be able to be acquired from local farmers who use them as feedlot bags. After the applied pressure to the bag, as described in the compression chamber slide, the solids content will increase to around 60 to 70% solids. The easiest use for our dewatered solids would be to combine it with other materials to make a fertile compost. CPAM is an ecologically non-toxic polymer that is not absorbed by plants, and it has already been disposed of in an agriculture setting in other countries, such as Germany. Because the dewatered solids are processed in bags, they will be easy to either carry to a compost pile or transport to a different local area. If composting on-site is desired, there are local nonprofits that you could partner with to add nutrients to your compost, such as Horizon Coffee, a micro-community farm with coffee, chicken, vegetables, quail, and rabbits, which is just a few hours away. The waste from this farm will add all necessary nutrients required for a good compost. If composting off-site is a more viable option, Santa Rosita Farm is a farm located within Gracias, Honduras, that already has solid waste management treatment for their own composting process.
Taking over from Melissa, we also did very light cost analysis for a design to get a better idea of how much our system might possibly cost to build. Please note that we quoted the prices based on international wholesalers and included tariffs that would be placed on shipping to Honduras. Unfortunately, local wholesalers did not respond to our requests for quotes, which very may have well been a result of our poor Spanish skills. In conclusion, despite the fact that Aguaclara's water filtration process is very efficient to begin with, there's always room to find a way to transform waste into something more useful. Our team's method of turning the sludge into viable soil and seed bags is a way to assist in helping nearby agricultural communities while maintaining environmentally friendly practices. This has been UWM's 2021 entry into the Spark Design Competition, and we thank you for your time in hearing our problem solution.
I'm happy to now introduce you to our Spark Challenge winners. Please, students, please take a moment to introduce yourselves, your major, what year you are at UWM.
Hey everyone, I'm Melissa. I'm currently a master's student in civil and environmental engineering, and I am actually very close to the end of my degree. My thesis defense is tomorrow morning, so very excited about that.
Hello, I'm Zach McFarland. I'm technically a senior, but I have 1 year left in mechanical engineering.
Hi, my name is Tessa Parrish. I am a senior here at UW-Milwaukee in biomedical engineering, and I graduate in December, so that's exciting.
Hi, my name is Hala Idrissi. My name is Hala Idrissi. I am currently a junior in mechanical engineering. I am very excited to finish.
Hi, my name is Kaveri. I am currently a junior in biomedical engineering.
Terrific, you guys. I have questions now specifically for some of you, so I'll call out your name if I think that it's directed at one of you. Otherwise, jump in and let us know what your thoughts are as we go. So Hala and Zach, to you both specifically, understand that you're both working in co-ops currently relating to the work that you did on the project. Can you tell us more about those work experiences that you have right now?
So I am currently co-op at Sub-Zero Wolf in Madison. Right now I am working at their Wolf facility in Fitchburg, which means that I work on a lot of the stoves and ovens that they design. Specifically, I'm working in quality, and at the company, it's a bit of a jack of all trades position. One of my long-term projects as a co-op is designing fixtures that they're going to be using in their test labs to hold their stoves and cooktops, which is really exciting.
Yeah, and so I would say my most relevant experience is with Engineers Without Borders. That's a nonprofit here at UWM. And we work to bring a freshwater gravity-fed system to Guatemala every year. And I'm currently the design lead for that this year. We're going to be implementing in Vucalvites in the Ichil Triangle.
Little off topic, but can we just give a little plug for the Engineers Without Borders Run for Water this Sunday?
Absolutely. So every year we do a 5K, and it raises a lot of the money. All of the profits go towards materials for the water system that we build every year. This year it starts at, I want to say 10 a.m. It's 9 or 10 a.m. And then you can find the link to sign up on any of our social media, Instagram, Facebook, or our Blogspot page as well.
And if somebody really wants to sign up just in, the mindset of competition, they can join the Stormwater Solutions Engineering team to help us be a bigger team.
Absolutely.
So then maybe just doubling up on that little introduction that you gave, because your work experience may not exactly what you did for this competition, but did participating in the competition influence or change your career path or your future goals?
Yeah, I mean, I'm definitely, well, combined with Engineers Without Borders, my co-op was DC Power, and I wanted to go into power, and I'm leaning a lot more towards water nonprofits and water treatment.
Yeah, it has definitely made me think more about what I want to major in for my master's, because I do want to eventually go back to school and study further. And so now I'm leaning more towards civil or environmental.
Jump over to Kaveri. Can you tell us about the Aguaclara nonprofit partners with the Spark competition? What was the project? Where was it located? And who is impacted by this project?
So Aguaclara is a nonprofit organization that builds gravity-powered systems that are cost-effective to filter the water, specifically the drinking water. So our project was to basically take that water and take the waste that comes out of the water and put it back in, and filter that, and so that it can be reused again. So the people that were impacted by this project were the people of Honduras, and Aguaclara has plants worldwide, but we focus specifically on the plants in Honduras.
And what was the process for developing the project? Like, did different team members take different aspects of the challenge, and how did you decide who should be spearheading which task?
Initially, we were all brainstorming ideas together, but then as we started working, we kind of decided Zach could do maybe the design process. Melissa did a lot of research on the polymer, and we all kind of came up with the design for the mechanical system towards the end.
I'm wondering who might have an answer about the question on, did you know what the MGD, the million gallons per day treatment requirement was going to be for this Gracias Honduras plant, and how your project would scale in terms of like, what would this cake look like at the end of one day of treatment?
I can take that. So they do 1 million gallons a day, but they ultimately only ended up with about a cubic meter of this like waste sludge at the end of every day or every 2 days. It obviously depended on, how much it rained, how much like debris had gotten into the water. But the sludge that we were working with was no more than like a cubic meter, maybe 2 cubic meters per day. And the tank that holds it is just 1 cubic meter. So we were given a pretty much set amount to start with for our portion. And then
go ahead.
And then for scaling, we just designed for the large woven bags for our plates.
That would be about 1 bag per day then, or what size are those bags?
The bags definitely wouldn't get filled up every single day. So the more viable solution would probably be to use the smaller bags, the feed bags.
When you guys were in sort of your R&D production time, did you actually build a scaled model, or was a lot of diagrams? How did you come up with the way that the little schematic on the video is charming, but I'm wondering if there was more to it than that when you came down to developing that?
So I can take this question, and I'd actually first like to build off a little bit on what Kaveri and Zach were saying about our design implementation. So my thesis is on sludge residuals and specifically wastewater. So I have a lot of connections at MMSD, and we were actually able to arrange a tour on how they deal with their solids. And so they kind of use a similar design where they have this gravity fed belt. Obviously they have electricity and we did not, but they add polymer right to the belt and it reduces the solids. And then they eventually can compact the solids using a rolling method. And so that's where we had that polypropylene bag as a cheap, because we didn't have the electricity. But we weren't able to actually create a figure with the time frame that we had. So we did only do those drawings, but we did, however, include specific angles and measurements that could have been used in the Honduras treatment plant. And so if you look at our design drawings, there are some numbers and equations thrown in there.
And just for those who are not maybe local, MMSD is Milwaukee Metropolitan Sewage District. One of those sewage districts that we are very proud to work for them and do a lot of work locally because they're really front runners, I think, in many areas of R&D and sustainability in the nation, if not beyond there. Do you know how the project proved to meet local water quality standards? If there are any local water quality standards in that region?
So we didn't actually change the design for the filtration of the water at all. We were just taking the byproduct of that and turning it into something that could be used. So Aguaclara already designed out their whole filtration system that met the water quality standards for each of the countries that they have those plants in. And then we just proposed an additional step to the end of that system.
How did Aguaclara feel about the design that you proposed, and do you know if they're going to try to implement that into their current system?
I think it was kind of mentioned as like a long-term possibility. With the design challenge, I think that there were some variables that maybe they didn't include just to make it a manageable project, but I think that they liked they must have liked our design if we won the challenge. But I'm not sure if they're going to implement it at all.
I remember them asking about scalability and if it would only work for larger plants or smaller plants, and if it could be retrofitted to fit into existing plants, or if it just had to be built in with the new water plants that they are going to be making as well. So yeah, they didn't give much indication on if they were going to pursue it or not, but it would be cool if they did.
You know, treating sewage is not something that we would really consider doing on a small scale in the US because we have places like our own local sewage district. But I'm curious if you've thought about implementing something like this, maybe for a fish tank or, you know, some other small stream of sewage waste stream that you could, you know, try to do your own small scale just for fun.
Yeah, so the one thing from this project was that because it was based off of drinking water and not of sewage, the solids that were being produced was mostly environmental things such as like sand and dirt. So that was actually where we had the hardest time as engineers deciding what to do with it in the end, because we know sewage has all of these chemicals and molecules that we can use for things such as biofuel, but there's not really much we can do with sand and dirt. So that was a big threshold of what we could do with it, but we could definitely implement our design to other things such as like streams.
When we get into the thinking about how your project actually worked out, remind me again what time frame that you guys had from the time of being presented with the opportunity till the design was required or submitted. It was a really short turnaround, right? Do you recall time frame?
I would say it was roughly about 2.5 weeks. So that first week was really more of an introductory period where they were explaining the scope of the project, giving us like all the information on where to find like these figures on like their website, what they did, a little bit about it. And then the next 2 weeks, they really let us loose. And it was structured in that we could meet with different engineers that worked at Ramble's to get a better idea of where we wanted to go with the design. But a lot of it was us researching and coming up with different versions of this and then getting feedback from our setup meeting.
What do you think really set your team apart from the other teams that were in the competition? Were you able to watch their presentations as well or interact with them in any way?
We were. So everybody was on a Slack together. And so like you could see the questions other teams were asking in the public channels, and they had like events scheduled throughout the 2 weeks that you could show up to with the other teams as well. And that was helpful because we could look at like the other questions other teams were asking and think of things for ourselves. But a lot of it was individual. And I think a lot of what set our team apart was we came up with more constraints than Ramble actually gave us. And so we looked at this as, okay, if we were actually going to build this, what would really work in this setting? And so we narrowed down the location that we were designing for. We narrowed down like what kind of environmental factors would be at this specific place. And I think that really helped our design shine.
Have any of you ever traveled to this region of the world or anywhere like that, that you could have a mental image about what you might be dealing with environmentally?
I have not been to Honduras, but my dad is from Morocco, and before the pandemic, we used to travel there yearly. And so in the cities, it's really, really well developed, and it's urbanized, and like they have good infrastructure. But as you get further out, especially into the mountains, the Atlas Mountains and the desert, the Sahara, a system like this would be really beneficial for people living there because it isn't as well developed, and a lot of the people living there are in like nomadic tribes. So it would be helpful to set up like systems of like water treatment or water access for them.
What did you learn about your own? I'm sorry, go ahead, Kaveri.
I was going to say, building off of Hala, I'm from India, so I know the climate and the humidity and everything. So it's kind of similar to what we were dealing with in the Honduras. And so like Hala said, in the city, it's more like developed, and there's more facilities that can do wastewater treatments and things like that. And there's electricity and power available in the bigger cities, while as you go into the country, or like the suburbs, there's not as much of that available. So it's more beneficial to have something that is gravity powered and just strictly mechanical.
And many of the water sources are surface water, probably rather than groundwater, correct? So you would be taking water off of a river, which is also collecting water from all of the runoff sources, and probably pretty polluted, where it might have a lot of organics and things that Melissa was concerned about not really being able to land spread and have a, good quality, use for it. When you were working with your team, it's difficult today because, through COVID, you're not really personally together all that much, right? It's probably working through Slack and a lot of other teams and various communication devices. How did you find with your own communication skills, like best ways to be able to collaborate? In my day, we'd all be sitting around a table in the, engineering and science building and be able to just chat it out. So what's different today and with this competition that you learned about your own communication style or skills?
So as far as communicating with other teams, we were completely virtual over Slack, as well as our industry experts that we got to do interviews with. So that, I don't know, personally, I struggled with the time zone thing. We had to set our meetings and then figure out what time that was here, which I struggle with that. But we also, working as a team together, we had a chat, but I think what worked best for us was in the last couple of days of the challenge, we reserved the quickie garage in the engineering building, and whenever any of us had time, we would just go in and out of that room. So sometimes, there'd be two of us in there, and sometimes the whole team would be there to just bounce ideas off of each other. And that's kind of when we got most of our work done, is when we had other people to kind of go off of and see what was good about the design and what could be altered a little bit to be better.
So you did get together in real time to be able to converse around a table. And that, I guess, is pretty, important to me to see, everybody has been so remote for the last 2 years that, especially when you're about to graduate and you've been in that atmosphere, now coming back into maybe an office environment, and that there is still that importance of being in person and, even maybe learning about your own leadership skills when you're in an in-person setting. Can you say anything about how did the leadership of the group pan out? Did you plan to have one person lead as a project manager, so to speak, and then, did someone else shine as a leader midway through?
I think we kind of all knew that Zach and Melissa were like they had background based on this experience. So Melissa did awesome with research of polymers, and she kind of took the lead on that and did a really awesome job. And then Zach did a lot of design work, and then I think Kaveri and I, just because our background isn't very related, we worked a little bit on our presentation, and then we kind of were there as just extra eyes, and were able to look out for just little things. And then Hala, she was awesome with our video. She did most of our editing. She was a rock star at the end when we were kind of pinched on time. But I think at the end, we all showed up and worked together really well.
Sometimes in industry, we do what's called a 360 review, where we'll review one another in a team or the staff, just to be able to give really honest but important feedback about your style and things that you could have done a little better and where you really shine. If you were going to give a little 360 review and maybe the most positive approach to each other, are there things you would like to say, especially, you know, with the folks who are heading off into the workplace in the near future, about, you know, what things they did really well that you want to let them know?
I would just like to, well, first, I guess I'll address that question. I think everyone participated amazingly to this project. Really, without every single one of us, we wouldn't have been able to do the design that we did. And so it was really great working with all of you guys, and I thank you for that. But I would also like to mention that 2 weeks does seem like a relatively long time frame for a project like this. Previous Spark Ramble competitions were only limited to 1 day. But the hardest thing about this project was that we're all super involved in the university. For instance, Tessa is the president of the Society of Women Engineers. Zach is working in Engineering Without Borders, and Hala, she's in a co-op, and the list goes on and on. So I think the hardest part about this project was just really finding a time where we could all get together and share all of the ideas we had. So we were lucky we were able to reserve that room, but it really came down to only 1 or 2 days where we were all able to get together and actually put our minds to working on this.
Anyone else to do a little like 360 review of one another on maybe your leadership skills or your ability to stay on task and complete something?
I'd just like to say everyone kind of stepped up to the plate when we needed them. Like we would bounce ideas off of each other. Everyone was super receptive to criticism of their ideas and changing their ideas. And then, yeah, when we needed something done, someone was always willing to step up. If they didn't know how to do it, they'd learn how to do it or get help doing it. So I'd just like to give everyone an A+ as a team.
Yeah, bouncing off of Melissa and Zach, I just wanted to say, like, everybody did amazingly at contributing to the project and making sure everyone could contribute something. Melissa and Zach definitely helped Tessa, Kaveri, and I, because we didn't have a whole lot of experience with designing for the real world, just learning the process and helping us get stuff done in order to contribute to the team. And I want to say, like, even though they're coming into this with like little experience, like designing for mechanical systems, Tessa and Kaveri like killed it with like learning so much about something that they had little exposure to in such a short amount of time.
We can come back to that question a little bit later if you guys feel like saying anything more. We're curious about when you got to see the other design competition videos. I'm sure it's at the very end after they're all submitted. Everything is fairly, you know, judged and then you get to see them. Did you watch any of them and think that was a really good idea? I wish we would have put that or incorporated that into our process as well.
So I can take this one. In the end, it seemed like all the teams were kind of editing their videos and submitting in the last like 2-3 hours that before the deadline. And so I wasn't doing any of the editing. So I was kind of searching on YouTube because that's where we submitted our projects. I was searching for all the other teams. So as soon as they came out, I would watch them. And I was a little bit nervous because everybody else seemed to go with lagoons or some sort of like really big project that's like not super space efficient, but maybe a little bit more natural. And so I was just more concerned that that's what Aguaclara was going for.
Maybe you missed the mark on that, huh?
Yeah.
You were way off base. Yeah.
Yeah, we were the only ones with a more mechanical design. Everyone else seemed to fall in suit with each other. And so
yeah. And I was at the opposite end of that. So I was the one compiling the final video and getting it uploaded and processed. And I looked down at my phone after I'd submitted and all these texts saying, "Are you sure? Oh my God, what's going on? I feel like we just lost." And it ended up, yeah, it ended up because I wasn't even looking at the other videos because I was so busy finishing our own and getting it polished. And it turned out being different really helped, and being the only mechanical design helped us stand out.
And really good that you could focus on the work at hand and not be distracted by your cell phone, which is such a hard thing to avoid these days, because you might have just changed direction all of a sudden and tried to add in something else.
Yeah, I definitely put it on silent mode and I got to work. I was at home because that's where my editing software was. So it really helped and able to like bring the project and let everybody shine and like with all their work.
Yeah, even at the final like awards ceremony / like recognition of all the teams, they showed each and every one of the videos, and we were all sitting in the same room together, just kind of looking at each other going, wow, that was a really good idea. That was really smart. Theirs is really good. And as we were listening to like the final results, we were all looking at each other and we were all like, that's such a good idea. That was that was awesome. And then I think we were all kind of in shock.
So you didn't know that you were the winners until after everyone had to see all the videos together at sort of a presentation and unveiling?
Yeah, and they unveiled from 3 to 1. So they started with third place, then second place, then first place, because all the top 3 teams all got Amazon gift cards. And so after they announced third and second, we were all kind of bummed out because we were like, oh man, we didn't make the cut. And then when they announced us, we just went crazy in that room.
Do you know how many total videos were submitted? Or schools submitted?
I think there were 6 or 7 teams that submitted their video. So we watched all of their videos in the order that the team names were, and our teams were numbered. And yeah, and then they had a debate, or they talked about like our videos and for about 10 minutes. And then they came back and we all regrouped with all the universities and the judges and the panel. And that's when they announced the winners.
Do you have any advice for any future students that might be doing this competition on like how to, what's the secret sauce? What's the formula they should follow to try to also follow in your footsteps and becoming winners?
I would recommend maybe not procrastinating as much as we did. Just the way our schedules worked out, the last couple of days worked best for us all to get together. But I would also say we were one of the teams that used most of our like meetings to meet with their industry experts, and those were super helpful to bounce ideas off of those experts because they kind of knew what the judges were going to be looking for. So that would be my 2 cents.
Kind of building off of Tessa, meeting with the industry experts also helped us with our design because they were able to give us an idea of what we were working with and how much sludge there was, and or just waste in general, that we could possibly design our mechanical system based off of that. So that made us, that I think put us ahead of the other teams in a way, because we were able to make our system more detailed. In our video, we also included a cost analysis, which I did notice that the other teams didn't really have. So I think that was also taken into consideration because that was one of the criteria that they.
And then building on that, I would say just having ideas and bouncing them off. Like, don't discredit any of your ideas would be a good piece of advice, because we probably had like 3 or 4 designs where the industry experts were like, that's kind of cool, but maybe don't do that. So just having plenty of ideas and not being afraid to like ask about them, and being open to criticism, being open to changing your design.
Yeah, and like within the team itself, like be confident in your abilities, but also know where like your knowledge like lacks. Like Melissa definitely took charge of getting like a lot of the environmental analysis and like chemical like analysis and like the safety of it done, because none of us had had experience with that. And so that also helped too. We were all very humble, like just about where our experience lies, but also what we knew. And then it ended up helping us because we were able to bounce our ideas off of each other in the last couple of days without, I guess, any fear of the others like saying, no, that's terrible, because we were all very honest with each other about like what we knew and what we thought.
I'd like to add one little last bit of advice, is that no matter how great your ideas are, you always really need to consider who is actually implementing your plan. And so I think what really set our group apart in the final design is that Aguaclara is a physics-based company. And so we implemented a physics-based mechanical design so that they could work with what they knew. Then an additional aspect of that is that we were warned that a lot of their plants struggle with, if there's a lot of wet residue, they struggle with mosquitoes and therefore malaria. And so a lot of other groups tried doing things such as on-site composting and lagoons, but we knew that that wasn't a good idea with where they were being implemented. And so we really used all of the information that they provided us with to design something that they would actually want and need.
You had talked about touring MMSD, and I'm wondering, being that this is a drinking water facility or treatment process, if you got into any of the drinking water tours or Milwaukee Water Works, for instance, to be able to see what their processes are for treating surface water.
We asked the superintendent of the Milwaukee Water Works, and they were not holding any tours because of the pandemic situation.
Understandable, right? Students, I'm wondering if there were any obstacles that you just did not foresee, and sometimes, you know, waiting till the last 3 days to jump in there makes all kinds of obstacles arise. But if there's anything that you would have said, a little bit of earlier planning or hindsight would have helped us in this particular area.
One thing that I noticed, I think we were all kind of worried about getting the video to be long enough, like having enough material, but in the end, so much was cut out. I think we probably sent in 12 to 15 minutes worth of material for a 5-minute video. So I think being a little bit more concise to make the editing easier would have helped a lot. Yeah, so planning to fit everything in to the time slot would have been a huge thing, I think.
Did you do any scheduling of your time that you knew you had, 2.5 weeks, and to try to break down the tasks into little bite-sized pieces through that whole 2.5 weeks, or?
So with our industry expo or industry experts, we knew that we wanted to meet with a lot of them, and we kind of focused in on what their expertise was in. And so we completed parts of our designs or ideas for our designs in that realm of things. But then I think there was a lot of times where we would meet with an expert and they would give us some criticism, and it would just kind of set us back, even though it was criticism, but I feel like we discredited a lot of our ideas because of experts a little earlier than maybe we should have, because I think our final design used a lot of aspects from our initial approaches that we had discredited because of something someone said. But I think we had a lot of ideas, and we did a lot of work in the initial weeks as well. It was just we needed the last couple of days for more motivation to just be decisive.
Jumping into what Tessa said, our final design actually used a pulley system, which was part of one of our initial designs that we had gotten feedback from one of the experts that they were like, that's not that great an idea. A lot of things can go wrong with the mechanical system that's pulley based. But then we ended up coming up with a few more iterations, and it ended up being the best version of what it could possibly be. And we ended up winning with this original pulley system design that we had initially scrapped. So we came full circle with that.
Did you get any specific feedback from the review panel as to what aspects they really appreciated about your design and maybe what things could have used a little more brushing up?
They really enjoyed the fact that they said no electricity, and we took that and ran with it. We went completely gravity based, and a lot of the other teams didn't necessarily do the same thing, or it was a very manual labor intensive process to set it up if it didn't have electricity involved. So a lot of their a lot of them had filtration gardens as the end product, but those are not only really expensive to build, but really, really labor intensive to set up without gravity or the use of heavy machinery.
I remember one thing that we were pretty nervous about that they ended up commenting on and saying that they really liked was that we had physical drawings instead of CAD drawings. That took me by surprise, because we did that because we were on a time crunch, and they ended up really liking it.
Yeah, we also did that because we went through so many designs. It was just faster to sketch it out and show all the parts to everybody that was in the room. And it ended up being one of the reasons it endeared us to them. They were like, that's really cute.
Another thing about knowing your audience, I think Melissa mentioned that before, is knowing who your client is and knowing maybe where are they coming from. And if they're not already engineers, sometimes engineers are the only people that can read an engineer drawing. And so if they're not, and they're just people from the public, the community members, what have you, that was a good way of showing. It's almost like a bit of a rendering so that they can understand what it feels like to use that device. What did you all use oh, go ahead, Zach. You had more input on that, huh?
Oh yeah, I was gonna say absolutely. And I mean, a lot of them, most of them are engineers, but they probably do the same thing. I feel like your initial ideas, you're not doing an entire CAD package drawing. You're just gonna sketch it down real quick, run it by, and then fine tune it before you throw it into CAD software. So, and I'm assuming that's kind of what their process looks like even.
What do you know about the company Ramble, who sponsors this competition?
I know they do a lot of like wastewater treatment in America specifically, on the West Coast. That's the gist of what I found from like their website. That was part of like our initial research. It was just getting a better idea of what the company sponsoring us did, and then getting a better idea of what the prop sponsor was, so Aguaclara. And so that's kind of what we did. We also kind of internet stalked a lot of the experts that they gave us. So we looked at like what they did at the company, maybe like looked at their LinkedIn page for like what their experiences were. So that way we had a better idea of what questions to ask them and like what their background lied in. And so I think that really helped us for getting a better gauge and a metric for like what kind of questions to ask these people.
So if I was at Ramble and I sponsored this, and we as a small firm have done a number of projects with Ramble, and they've been a really great client for us to work with, I would think that you guys would be at the top of their list for incoming and new employees if they're looking for new hires or new grads. What kind of thing might you like to say to kind of give you your own pitch? Especially if you're going to be looking for a co-op or a professional position for Ramble or for anybody else who might be listening that's looking for new incoming engineers. It's kind of your time to give your couple minutes of why hire me. Anybody want to start? Hala, you're on main screen right now.
So I guess I'll start then. I guess one of my favorite things with my past work experiences and like at my co-op right now is my supervisor is there for me when I need it, and there to help me like with new concepts or to like bounce like a lot of my ideas off of. But he also gives me a lot of free reign with working and releasing me into the wild and on projects. And I think that has really helped me grow. I'm not just like as a student and somebody who's learning engineering, but also like just as an engineer, it's forced me to gain new skills, and he'll usually like give me a list of people that'll like help me with this project or people that I should go to for questions about data or like references on like design fixtures. And so it's really given me a lot of skills in that way. And I think it has really allowed me to become just a better engineer in general.
I want to say something about Ramble. Ramble has a presence in Milwaukee in the US. It's a global company, has like 16,000 employees, was founded in Denmark in 1945. And they work in many sustainable solutions, buildings, transportation, water, environment, health, architecture, landscape, energy, management, consulting. So it's a very big company. And I understand that Ramble asked the students if they were interested in having a co-op with a company. So they gave this opportunity to the students.
Melissa, I think you're getting close to, and maybe you've already gotten a future employer in mind. Would you like to speak on your why would someone want to hire me?
Sure. So I think what this project proved for not only me, but for everyone in this group is that we're extremely well-rounded individuals that just have critical thinking skills I think any employer would want to see in their employees. My background is actually super diverse. My undergraduate degree was in biology and chemistry. I worked in healthcare for 6 years, and then I decided to go back and pursue a more environmental route. And so I just started my engineering career about 2 years ago, and I absolutely love it. I love being able to really do these think tank style projects all the time and apply my diverse background. And so I think what a lot of employers tend to do is find the person with the most specific experience. But what I and what the rest of the group really proved is that we all had experience that wasn't directly applicable to this project, and we still made a really great outcome. And so sometimes it is the people with a diverse background and not the people with an applicable background that can really make a great product.
That's a great statement for diversifying your project team from, all the different regions of diversity and what you can bring things in, because it's always 1 + 1 = way more than 2. There's definitely a lot more going on when you can synergize. Nice. Zach, Tessa, Kaveri, I don't know that we've heard from you. If you're interested in looking for a co-op or intern position, or if you're ready for graduation soon, anything you'd like to say about your interests? Or
Yeah, as I'm kind of looking for internships, it's a little difficult to find internships in the biomedical engineering field in this area. There's kind of a hub for it in Minneapolis, but that's kind of led me to applying for internships that aren't necessarily biomedical engineering, that are more mechanical or electrical. So I like to bring up this project in my elevator pitch just to kind of show that I have the skill set to pick up other engineering ideas, that while my background is in biomedical engineering, I also can learn and adapt to be a valuable player in a different field of engineering.
Kind of building off of what Tessa said, I think as biomedical engineers, we don't have very many opportunities. So getting internships and co-ops is more difficult. But I think what this project proved to me was that I can, even though I don't have any background with actually building or engineering anything really, I can still be a valuable part of the team, and I can still have critical thinking skills that I can bring to the table. I can still learn and design things pretty quick. And my background with research really, I think, helps with that, because it helps me understand things a lot better. So.
And then for me, I like to talk about my experience with engineering. I have experience designing water systems, obviously with Engineers Without Borders and with this project as well. And then I also have experience with DC power systems. But something that doesn't show up as much on my resume is I did 3.5 years of an advertising and public relations degree as well. So I do have experience with communications and communicating with clients, bartending, and a lot of these more social jobs have really helped shape me as well. And so on top of engineering, I also have just a variety of past experiences.
Great. Good job, you guys. I have one last question for everybody, or unless it was a one team decision. How did you all spend the funds that you received as a reward for or award for the competition?
So you go ahead.
Okay. So we ended up each getting about $600 per person on Amazon gift cards. And that was right before Christmas. So a lot of mine went to buying Christmas presents for my family and my friends on Amazon.
That's what I did with a lot of mine, but I'm also getting married in June, so I bought a lot of wedding stuff too.
I have not spent most of my money, but I did spend it on new AirPod Pros, so I guess that does take a big chunk of it. So
I also bought myself the most expensive pillow I've ever owned, and it's very nice. You got to treat yourself a little bit.
Yeah, I got.
Anyone else? Otherwise, I believe if we don't have any questions coming in from the audience, I think we may be closing. Thank you all for joining us today for the Mobile Master.
Can I add something?
Yes, jump right in, please.
Yeah, okay. So I understand that there are alumni looking at this chat, and I want to emphasize again, the quality of our students, our graduates. This team came ahead of major universities such as Purdue, the University of Pennsylvania, Northwestern University, the University of Rochester, and Temple University, Villanova University. So we have every reason to be proud of our students and graduates.
Thank you, Professor Bravo. And we are proud that at least many of my staff members have been Dr. Bravo students in the past. So I think it's fun for us to see you here today, but also to be able to share, what a legacy you have promoted in the local area here to our engineers. We're very thankful for that. With that, I believe that we're going to wrap this up. We want to thank everyone for being here today, bringing clean water to remote areas. The UWM students take first place in this National Clean Water Design Challenge. A profound thanks to Professor Hector Bravo for helping organize this panel and introducing us to these outstanding students. And thank you, students, for making us so proud and sharing the work that you did with us. Please visit alumni.uwm.edu/Mobile Master Chats to learn more about the Mobile Master Chat series and see upcoming presentations and view past recordings. Thank you.